All right, so today's lesson is going to be about two population inference. We're going to discuss three different techniques within these next three videos. Some big things to note is that at least three different methods. This one's going to be two independent population means t-test. Next video is going to be the paired t-test. The next one's going to be two independent population proportions test. Ideally, after this, you should be able to determine the difference between an experiment and an observational study, random assignment and random sampling, hypothesis testing, and confidence intervals regarding these techniques, and the implications of zero. I like to talk about these key formulas. As you can see, there is a zero in each and every one of them, and you'll see why throughout the video. I mean, towards the end of the video of each one of these videos, because the zero has a special meaning. So why don't you all go ahead and take a moment and not only read this, participate in the experiment. I'll show you. So if you go to the online app, and you click on this, this will take you to a memory game, and you can play the memory game. So it's going to reveal a secret. Sorry, first select a number between 0 and 50. It's going to reveal a secret, and then you have to memorize it. So go ahead and do that. So what I was trying to do here was trying to figure out, does the number that a student selects have an impact on the number of letters they're able to memorize of the secret? So ideally, you would have done the same thing. You either selected any number between 0 to 50. And if you notice, if you look closely, if you selected an even number, the actual secret password was "I love to eat pizza." Okay, "I love to eat pizza." Whereas if you selected an odd number, it was "I love to eat pizza," but the letters were scrambled. The letters were scrambled. So in terms of logic, which one do you think is going to be easier to memorize, even or odd? Ideally, you would have said even. It should have been easier for individuals to actually memorize the secret password if they selected an even number. So what's interesting about that is that I legitimately randomly assigned each person to a treatment by them selecting a number. So they were randomly assigned a treatment based on the number that they selected. Okay, so take note of that. Okay, and then in terms of random sampling, how that's different from random sampling is that I would just randomly grab students or randomly ask students to participate in a study, for example. That would be an example of random sampling. Or if I were to go in front of the library and randomly ask students there to participate, that would be a convenient sample. Whereas what I did here, I randomly assigned students to either get a password in order or a password that was scrambled based on the number that they selected. So here's the data. All right, summary statistics look like this. And this is from a class a couple years ago. All right, summary statistics look like this. The sample size for each selection, the sample mean from each group, and then the sample standard deviation. As you can see, the sample mean is a lot larger for in order the even versus scrambled odd, because it's in order, it's easier for them to memorize. Okay? And so then here is the data. It's a little wonky, but here you have in order being a lot larger than scrambled. One of the biggest caveats here is that, at least the things to notice, that you cannot determine the mean from box plots. You can only determine the median. These horizontal lines are the median. But even so, the median for in order is a lot larger than scrambled. Okay. Last but not least, our analysis, things that are worth noting, our test statistic, okay, 7.3842, our degrees of freedom, 88, okay, our p-value, 8.3 times 10, 8.23 times 10 to the negative 11, okay. Is that a small or a big number? That's a huge number. That's a really small number. That's a very, very small number. My apologies, because it's times 10 to the negative 11. One last thing to highlight in terms of this analysis is that our confidence interval, right, they're both the lower bound as well as the upper bound are both positive. Both of these values are positive, indicating that 0 is not plausible as a difference between the population means, okay? 0 is not plausible. So with that being the case, since this is our first time learning these techniques, you should be able to answer the very first 4 questions, okay, the very first 4 questions, and then we'll do the next 6 questions or 7 questions together, but at least do the next 4 by yourselves. Okay, so something that I need to make sure that I know is that this data that's used in this output, it's from a different sample. What I mean by that is that this analysis, the output that we're going to work with, or at least the analysis here, is from a different sample, whereas these numbers that we have up here is from another sample. So we're going to get 2 different test statistics, 2 different confidence intervals based on these numbers versus these numbers, okay, just in case you've already noticed that. So that being the case, we can go ahead and start answering some of these questions. What's the PSO, population of interest, the sample, and the observational unit? The population of interest is all Cal Poly students. The sample is the 90 students that are from our business class. They are a convenient sample, yes, but I randomly assign students to either treatment, okay? So it's important to note that. And then last but not least, a Cal Poly student is going to be the observational unit. So the question here, or at least the next question, or big question, is how many variables do we see here? All right, so if you look at the box plot, okay, let's take a moment here. We should note that there are only 2 variables, the y-axis, the x-axis. The y-axis is the number of letters memorized, and the x-axis is going to be the what treatment they experienced, the group, right? So I would argue that this is, again, 2 variables, okay? On the x-axis, it's going to be our explanatory variable. That's explaining the variability in our y-axis variable, the response variable, the number of letters memorized, okay? So we have 2 variables, the explanatory, which is the treatment, and then the response, which is the number of letters memorized. So since our explanatory variable has 2 levels, we'll consider that to be categorical binary. And since our numbers of letters is a numerical measurement, we're going to consider that to be a quantitative variable. So again, we have the explanatory variable, whether they select even or odd, scramble or an order, which is categorical binary. And the type of numbers memorized is the response, which is quantitative. Okay. So then the research question is whether the number of letters memorized is affected by what someone selects in terms of even or odd. Okay. More specifically, or at least using statistical terminologies, is the population mean of number of letters memorized the same for the students who selected an even number versus those that selected an odd number? Is the population mean the same? And the technique that we're using to answer this question is the 2 independent population means t-test. Okay. We'll talk more about pooled versus Welch in a little bit, but just this is the general name here. From there, we have to state the parameter of interest as well as the statistic of interest. So first, let's look at the parameter of interest. The parameter of interest is always going to be dealing, when it comes with a quantitative variable, the idea of mu, okay? In this situation, how many mu's do we have since we have 2 groups? Ideally, you should have said 2 mu's, okay, 2 mu's. Okay, so it's the difference between the mu's. Mu E minus mu O, where E is even, or in order, or O is odd, scrambled. You could have done mu 1, mu 2, but you have to specify what 1 and 2 denote. And this difference is the difference between the population mean number of letters memorized by students who selected an even number and those that selected an odd number. So be aware of that, okay? E minus O. And how do we estimate this parameter of interest? Instead of using mu's, we should use X bars, okay? So state the summary statistic and use to estimate the parameter of interest. That's X bar E minus X bar O, which are from our summary statistics, 13.93 minus 8.70, which gives us 5.23. and that's going to be our point estimate, or in other words, our estimate for the parameter of interest. Okay, so now finally, what's the difference between pooled versus Welch's? When it comes to the pooled t-test, what we're doing is we're assuming that the variabilities are approximately the same. Okay, the variability is approximately the same. The way you test this is by looking at S max divided by S min. And if that is less than or equal to 2, the standard deviations are approximately equal. Okay, so just so you can get a better sense of what I'm saying here is that 3 divided by 2, right, would give us 1.5. And I'm arguing that therefore the variability is about the same because it's less than or equal to 2. But let's say, for example, we had 2 standard deviations, 7 divided by 1, right? Where one standard deviation is 7, the other standard deviation is 1. This difference is 7. This quotient is 7. That tells us that there's a huge difference between these variabilities. Okay, so that's how that works. And so we're able to reject the null hypothesis and make the right decision regarding the null when we use a pooled standard deviation, when we do a pooled t-test. When they're not approximately equal, we use a weighted test, what we call the Welch's t-test. Okay, this is a weight between both of the variances. Okay, so with that being said, based on these standard deviations, I'm pretty sure we should be using a pooled, right? 3.62 divided by 2.5 is less than 2. Okay, it's less than 2. All right, so then the non-alternative hypotheses, as you can see, I'm writing it in this particular format. Mu E minus mu O is equal to 0, meaning that the population means are the same. Another way of writing this easily could be that mu E is equal to mu O. Okay. Same thing here in terms of the alternative hypothesis. If this was the alternative, we can say that A does not equal mu O. Mu E does not equal mu O. Okay? So with that being said, this is the non-alternative. The assumptions that need to be met is that random sampling or random assignment needs to have been done in order for us to make conclusions regarding this analysis, 2 independent groups, and approximately the data follow a normal distribution. Okay. From there, we need to calculate the test statistic. So this is the equation to calculate the test statistic. X bar 1 minus X bar 2, which is our point estimate, minus 0, okay, and then divided by our standard error. Okay. So with that being said, this tells me that, actually, I didn't provide the work for this. I just provide the number. And we get 7.895. Okay, 7.895 is our test statistic, which is a lot greater than 3.5. Okay, whenever we have a test statistic that's greater than 3.5 or less than negative 3.5 for the 2 independent population means t-test, because it follows a t-distribution, that means that our p-value is going to be extremely small. That means our p-value is going to be extremely small, indicating that we have extremely strong evidence against the null hypothesis and we should reject it. Okay, so that's the implications of a test statistic for from a t-distribution being extremely large. Thus, we should reject the null hypothesis. Okay. So then here is the logic behind our confidence interval. We're going to create a 99% confidence interval with a critical value of 2.6329. Here's the relative math. And again, you can see 0 is not plausible. 0 is not possible. So we are 99% confident that the difference between the population mean number of letters memorized by the in order and the scramble group is in between 3.49 and 6.97. Okay, so the reason why I keep harping on this idea of 0 from our test statistic,